Hello. Good afternoon, everyone. My name is Kaiyu, and I'm a PhD student in School of Built Environment in UNSW. And today I'm going to introduce my research that is going to develop an integrated platform that to integrate multi-source material data to support the building product assembly design. And my background combines both the architecture design with the industrial practice. I have an architecture background, and I used to work as a product designer for an web-based interior design software. And also, this experience make me realize that the gap between the current tool provides and the needs that the designers really want. So the material selections can impact to up to 70% of the construction project costs. So it is very important for the designers to select and compare the materials based on the project requirements. Here are several challenges that we are currently faced with. First is that the material data can come from different platforms, and these platforms have no access with each other. The designers can search for some material inspirations on Pinterest, and they can download some material specifications from a supplier's website, maybe in PDF format. And they can also search for some sustainable metrics from EPD documents, which is Environmental Product Declaration. And let's take this wall component with window. For example, a designer can design this component based in the since the family in Revit, but the actual detailed material properties are from those diverse sources, which means it could take a lot of time for the designers to search these informations across different platforms. And sometimes they need to make a design decisions with incomplete information. And also the manual input and updates of these material properties can be very labor consuming. Currently, there are several online BIM libraries that provide material data to download for designers, but this kind of information exchange is based on files in proprietary formats. And also, some platforms, for example, BIM object provides connections between this platform and Revit through some plugins. But this kind of connection is on the software level, not on the data level, which means if the designer wants to access this component from another software, this kind of connection can be lost. So this research focuses on the disconnection problem between two stakeholders. The first is the designer who needs comprehensive data to make a design decision, and also together with the supplier who have this data but are struggle to make it very accessible for others. And in the middle, this platform should facilitate the integration of the multi-source material data that enable designers to search and select materials very efficient. And this kind of platform should based on an appropriate data management approach together with the materials classification that is suitable for their workflow. In this research, the products are understood as construction items with the intended functions, such as a wall component or a floor component, and the materials are understood as the consistent items of these construction products, such as glass or ceramic tiles or wood. And through the literature review, here are several findings. The first is currently there are no standardized material property classification across different platforms. There are several international construction classifications, such as uniformat and master format, but they miss the detailed material properties in their classification. In the below image shows one research that tries to extend master format to develop classification for not only the materials, but also for the material properties. But it only limits to the performance properties. But in the actual design process, the visual attributes such as the color, the texture, the pattern is also very important for the designers to select materials. And also, this research found that the material selection complexity would require a complex query, which means it could need, like, for example, multiple keyword search, multiple table joins, and combination of different logic. And the literature review continue with data exchange. Compare with file-based exchange with database exchange, the central database approach to manage data is better at its data level management and also provide a single source of truth. And among several different kinds of database, the classical relational database is better at dealing with complex queries, but it can meet some challenges to represent many-to-many relationships between the material categories and material properties, since it adopts a fixed table structure. And also, we all know that writing very complex SQL language for the non-technical background designers can be very difficult. So with the recently, the development of the large language model enhanced agent can transform users' natural language into database query language, but still there are several gaps exist between the user's unstructured and unstable natural language and with the requirements for the accurate and structured input to the database. This research aims to develop an integrated platform that addresses these challenges through three key components. The first is to establish a more detailed material classification framework through extending some existing construction classification framework. And the second is to develop and implement a data schema for relational database to represent the material hierarchies and the relationships. And last, instead of navigating through some very complex filters on the interface, the research aims to develop a prototype incorporating LLM for designers to search and select materials in natural language. Responding to the objectives, several research questions have been proposed and classified into three groups, which is the data classification, data representation and storage, and platform development. For the first group, the research is going to find it is possible to define a streamlined workflow for the designers to select materials. And the research also wants to find what are the essential material properties that should be included in this platform. And this research are also going to explore what's the most appropriate classification system. And in the next group, the research is going to discover what data schema can be designed to represent these material hierarchies and relationships. And the research also going to explore what's the suitable deployment method for this database. In the third research question group, this research is going to do some experiments with LLM, trying to explore what's the target schema described in the prompt example to extract material properties from the material specifications, and also to maybe some prompt templates need to be developed to match with the material data schema to perform natural language query. Based on the research questions, an action design research methodology will be conducted into three parts. The first part is the empirical study, that including the field study with practicing architects to understand their workflow and also confirm the essential material properties that should be that is also very important when they are making some design decisions. And in the second step, that is going with the database development, such as data schema design, and also design some associate tables to represent the many-to-many relationships in this material classification. And the third part is the system implementation and validation. In this part, the research will connect the Revit with external database through Dynamo, and also do some experiments with LLM, for example, to extract material data, and also to do some queries for the database. And also after that, usability testing will be conducted to test the effectiveness of this platform. And this research aims to contribute to the industry and to the academic. For the practice architects, functional prototype aims to develop, improve the material data search efficiency and accuracy. And for the academic, this research aims to contribute a novel material property classification framework that is suitable for the design stage. And also it can contribute a LLM enhanced material database query framework. And thank you, that's the end of my presentation.
Thank you. So any questions from the floor? Where is that?
Thank you. Thank you for your presentation. I had a PhD student. Unfortunately, he passed away before submitting, and he was working on haptic aesthetics and the human touch elements of materials. And it was a really good study in the architectural space around the emotional connection to materials. I really like what you present, but I feel that that haptic aesthetic and the human side of what you're doing is missing. And I'm wondering whether there's thought to be able to incorporate that into a database, because it seems quite digital and selections made without touching and feeling materials, and therefore might miss an opportunity around the human elements to this research.
Yeah, thank you. And I think related with the human impact of these materials, I think it's more about sense and about the color and what it looks like appearance. I think in this research, it's going to define what are these attributes included in these materials, like color, the texture, and also shape. And this research, I think some research can help to represent these kind of attributes, like how to represent color in different color systems. And I'm also going to define which attributes are not very well represented. And I understand apparently there are so many things related with human behavior about these materials, but I will try to cover the properties that is useful when the designer to select the materials.
Any other questions?
I'm trying to formulate it.
Okay.
I'll get started. Okay, so just getting back to some of the comments that we've made to other PhD presentations. There are already databases in place that people go to for specification and selection, and so they're like, just from a practical sense, I think you're getting into a little bit of a can of worms in terms of potentially replacing those types of systems, which is why I like the way that you described as developing a schema. I'm skeptical about whether it is actually like a repository that people can go to then collect data from. But on that note with the schema, I'm quite interested in, and sort of parroting what was just said, the plethora of different parameters that people might want in terms of specifying materials, furniture, etc. There are a lot of suppliers out there that are coming up with their own schemas. There are standards out there for materials when it relates to fire or code compliance, but there's a bunch of engineers, sitting in the room potentially, that might get left out when looking at particular materials. And I think one of the critical ones is ESD. Like, if there was actually a decent schema that we can work to, that every supplier can agree to working with, then that becomes a really useful apples versus apples comparison for some of these other systems that people are talking about, that we right now we've had to rely on the EPIC database for LCA or the I forget what it's called, but the product aware. Like a lot of effort's gone into product aware, right? Product aware is almost like it's got a whole bunch of information in there that this needs, right? There's all these systems that you could piggyback on and try and rope together to get to where we need where you're trying to go. It's a really big endeavor, and I think that just the exercise of working out how those disparate professions come together and agree at like a single schema is probably a mammoth task. So, is that what you're committing to?
Yeah, I think about the schema. I think your questions is also related with the effectiveness of this schema.
Yeah.
Can every engineers like on the spot can agree with this schema? I think first I have to refer to the FC schema, because FC have some classification to the materials, and also FC have a bunch of properties inside of the property sets, but it's not enough. It actually, I think they have more properties that not included in the FC schema, that I should do some exploration, extend on that. And also, I think related to the schema that should be tested by some engineers and by some practicing architects. I think I need to maybe do a usability testing with some practicing architects to gather their feedback about this schema, because each one maybe have different opinions, but I should to collect the common sense about this schema and to maybe refine it after several rounds of the schema. But its base is on the FC schema for the material and properties. Thank you, Andrew.
Just a thought. I guess was first introduced to this sort of idea when I was an undergrad, and our professional practice tutor happened to also have done this kind of project, I think in the early 90s. And he said they spent a lot of time and government money on developing this kind of schema. And ultimately it didn't work out. I think he's still alive. Right.
What did you kill him?
It might have been me. But it would be interesting potentially to think about that as a kind of historical exercise of all the times that people have tried to do this and failed, because that might give you at least as much insight into what you should do as asking a bunch of people who are coming to this problem for the first time whether they think it's a good idea or not. Have a tendency to just say, yeah, that looks good. So it'd be interesting to come at it from both ends.
Yes, thank you. Yeah, I will look for some like historical research on if why they are failed about to design this schema.
Yeah, I don't know. You might have to just call him.
But even just talk to the businesses that run the specification tools. Like there are people out there that are doing this right now that are providing that service, and they'll have comments on it. Obviously, like learn from what they've done. But if anything, talking to architects might be the wrong thing. Yes.
Yeah, I like have a somewhat casual communication with some designers, but I think yes, it's also my next step to collaborate with my industrial partners, maybe Cox or maybe architects.
Don't talk to us. Go get the contact details. Like go find all this. If you're going to talk to us, find out what tools we use to specify materials, and then go talk to those people who make those tools.
Mm-hmm.
They'll have way more info on this than us.
Yeah, I will do that when doing the field study.
Yes, good.
Any other questions, comments?
Thanks for your presentation. Brings up a lot. One question I have is whether, with the advent of refining materials in relation to ESD, and closed loop sort of scenarios, whether that's a layer you've thought about and if it is in fact a central layer to the LLMs and how they might react to information that's out there around materials and actually give, I guess, a focal point around sustainability is an obvious starting point.
Okay, thank you. So let me recap. Are you going to want me to introduce what's the central layer for this database, or do you want to know how to interact with the central database through LLM?
Oh, sorry. I guess my question is, in designing for a circular future, how can your tools or your schema actually facilitate that and promote that? And to the points raised, there's probably some key databases that obviously have thousands of materials to that effect.
Yeah, okay. So I think first for the data source for this database, actually I have examined on one material libraries that are called 2015 libraries that is also related with to calculate the carbon emission for each materials. And it has like, I think more than 10,000, maybe more than that. I remember like more than 10,000 of materials in that libraries, and it's includes some carbon emission data for each type of materials. And through that platform, designers can calculate the carbon emission for their building products by combining each carbon information of different materials. And my examination for that libraries is that it's also it has like maybe more than 800 of properties for each materials, but for the design stage, not most of these properties are used. So, and also we all know that if we have 800 of properties in the libraries, it could be a very huge data schema. And so that's why I need to confirm with the practicing architects to know what's the properties that is useful and should be included in my platform just for the design stage. And in the design stage, it can be connected with some performance properties and some visual properties. And after that, I can be clear more about what properties should be included in my platform. And maybe some will cover about the sustainable properties.
Okay, we've got 5 minutes left, so one last question.
What I wanted to say is like for this type of systems, my understanding is the validity of the system becomes like how many users would use that system, and like what is the projected market for you, like what's the like how many people will use your system. And there are already, as it's been talked about, there are already like schemas out there that like I don't know Omniclass or like IFC or what like is that can capture to some extent, or you can add your own property to that specific file format within the existing system that people use. So I suppose my question is, what do you see the chances of people adopting a new schema to already very busy workspace with a lot of tools there? Like, how would you see they will commit to use that rather than something like you say, IFC that already exists and people want to use that?
Yeah, thank you. I think first, I know there are some platforms that can already capture some material informations, and I actually I have downloaded most of the material properties to material specifications from that website to look for some materials, what it really looks like. And for my understanding is that first, these platforms, they are mainly based on the files. We can download some SketchUp file, we can download some random files, and these files can include some material information for the designers to use. And actually, I have some casual conversation with designers, and the problem is that first, maybe one designer, they want to design something in Revit, but this website, they only provide these files in SketchUp format, so the designer can use it. They need to do some format transformation, and it can lose some material information. And also, it's also related with the updates for this information because it's based in files. Maybe this file can be like maybe 5 years ago. They have some material information for that files, but this when the designers actually use this material component in their model, they may find that the suppliers have already updated this information and no longer use it. So that's a problem with some of the current platforms. And about how many users will use this platform, I think that question I can't answer now because mainly for this platform is target for the designers who need to make some design decisions, especially during the design development stage and detailed design stage, like to select this material for this platform. And it can be architectural designer or interior designer who need to do some selection for the materials. And this can come from some big architectural company, but it can also from some small architectural companies. But the most important thing, I think, is to first define what properties, what materials are universally be utilized, and what materials can be just used for that company. And it can have different level for the libraries of this database. I think that's one thing I need to communicate with not only big design company, but also with some small design companies to see their requirements.
Okay, and that brings us to time. Thank you very much, Kaiyu.